All right, so we are going to do the period, frequency, pendulum stuff. So let's do number 7. A metronome, a device used by many musicians to get a desired rhythm for a musical piece. If a metronome is clicking back and forth with a frequency of 0.5 hertz, what is the period of the metronome? All right, so a metronome is one of those things, all it does is keep beats, like bing, 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 bing. So it keeps a beat. That's all it is. So they give us frequency, 0.5 hertz, and they want period, which is big T. So frequency, little f, period, big T. So there's a couple ways to figure this out. We have a couple of formulas. On this page, there's a formula that we're not going to use. It's a little harder. And then there's another formula that's a little bit easier on the previous page right here. So it's pretty much a formula you can use to find frequency or period. And they're just inverse of each other. So we've written down what they give us, which is frequency. We want period. So the formula is period equals 1 over frequency. So that's the formula. Let's get that straight. That's the formula to find period. And if we wanted to find frequency, frequency equals 1 over period. Right? So if that's what they give us, we can use either one of these formulas. Something important to note, because a lot of times people get confused, frequency or period. Period is always in seconds. So it's like one revolution or instance of this thing moving is how many seconds, and that amount of seconds is the period. Whereas the frequency is how many revolutions in 1 second, right? So don't worry about it if you already know it or if it's confusing. Just know that this is, let's see, times per second. So, all right, so we have our frequency of 0.5. So what we're going to do is we're going to use our period formula, which is 1 over frequency, which is 0.5, is going to give us our period. So in this case, the period is 2. And remember, because we said it is period, it's in seconds, right? So 2 seconds is our answer. So 2 seconds. I'm going to box that just to kind of clear it up. All right, let's keep rolling. We got a few more. I don't want to make a short video. So let's do number 8. So, is that clear? Cool. Many amusement parks feature a ride in which a giant ship swings back and forth. This is pretty much a pendulum. Pendulum is like back, forth. Okay, there we go. Back, forth, back, forth. So, it swings back and forth. So like at Six Flags, the ship. Pretty fun. The period of the ship is 8 seconds. What is the frequency of the ship? So, first thing we're going to do is what we always do is we write what we have. So they give us the period. So big T equals 8 seconds, because we know period is in seconds and frequency is in hertz. So we don't have anything else. It's a pendulum, so we're just going to do our regular old easy formula we just talked about. So we don't have frequency. I'm just going to put frequency equals. So we're going to do frequency equals 1 over period. I'm going to write my formula first. Now I'm going to plug it in. Frequency equals 1 over 8. 1/8. We want to turn that into an actual number. We don't want a fraction. So you do it in the calculator, and I will just look at the answer sheet. So our frequency is 0.125 hertz. Hz for hertz. So that's our answer. We're going to go ahead and put it in the answer box, of course. This is pretty easy, pretty straightforward. I mean, this is not too challenging, but make sure you show your work. That's the important part. All right, number 9. Tegan, a trapeze artist, swings from a 2.5 meter long trapeze high above a 3-ring circus. Cool. What is his period of swing is question A, and would Tegan's period of swing change if he were more massive? Okay, so let's focus on question A. What is his period of swing? So they don't, let's see, I have a circus. What is his period of swing? All right, so they don't give us anything really. They give us the length of the cord. So that's good. So we have our length, and that is 2.5 meters, right? So our length. So we're probably going to use a different formula for this one. We also know the gravity because we're on Earth. So in this formula, they have it labeled as little g for gravity. It's pretty much acceleration for gravity, but so you don't get confused, I'm going to use the same thing they used on the previous page. Little g for gravity is 9.8. Okay, so with that being said, okay, I have a little bit of time. Let's see, and what do we want? We want period. So I'm going to write what we want right over here. T equals, I'm just going to write it because that's what we're trying to find. So let's go back to our previous formulas. It is the period equals, it's the big one, right? So let's write our formula down. Period equals 2 pi on the square root, this is a fraction in the square root, of length over gravity. So a lot of stuff going on, but that's okay. We know we're trying to find the period, so we've written our formula. Next, let's write, let's plug in everything we got. So period equals, I'm going to leave pi as pi because there's a pi button on the calculator, so I don't really want to mess with that. On the square root of my length is 2.5, so 2.5 over gravity, which is 9.8. So there we go. All right. With that being said, let's do our formula. So what we can do is we can do the square root of 2.5 over 9.8. This isn't a real complicated one because everything's sort of there. So 2 times pi, and if you want to keep that together and then do 2.5 divided by 9.8, take the square root of that. So pretty much do this first. I'll dotted line it. Divide it, square root that, multiply it by 2 pi. There's not really a lot of moving around, so I don't have a whole lot of other stuff to show you other than you should get, we know period is in seconds, so you, excuse me, 3.2 seconds. So that's our answer A, 3.2, S-E-C. I'm going to box it even though it's on there. All right, answer B. Would Tegan's period of swing change if he were more massive? So if he weighed a lot more massive guy, or girl, or whoever Tegan is, would the period change? The length of time it took him to swing back and forth? Well, just look at the formula. I mean, a lot of these, don't overthink it. Look at the formula. Would this T change if his mass was different? Well, is mass anywhere in here? Mass isn't length, and mass isn't this gravity, which is a constant. It's always 9.8. So it doesn't matter if the mass changed. The period would stay the same based on this formula. All we're focused on is the formula. So for that, our answer is no. Pretty easy, pretty straightforward. We don't have to overthink it. It's there. We look at the formula. All right, let's do number 10 so the video is not too long. Danielle is pushing her twin Daniel on a swing that hangs from a tree 2 meters long. What frequency will Danielle have to push Daniel as he swings? I wish they didn't use those names, but that's okay. So our length is 2. I see that we are on Earth, so we're going to say gravity is still 9.8. We want frequency, and our formula with this is typically period. So this looks like a two-parter. So with that being said, let's plug everything in. Period equals 2 pi on the square root of length over gravity. Now let's plug our stuff in. Period equals 2 pi on the square root of, our length is 2. I'd highlight it if I had a highlighter, over 9.8. Let's make my square root a little bit bigger. So our period, you work that out in the calculator, you should get, we know periods in seconds. Period equals 2.8 seconds. Awesome. So we have our period. But do they want period? No. They want frequency, right? So we got to take this period that we now have, 2.8 seconds, because period's in seconds, and we got to turn that into frequency. Well, the hard part's pretty much done. Now we got to do the frequency part, which we know our formula for frequency is 1 over period. So that's pretty simple. So we just plug this number in here and do our simple math. So frequency equals, am I still on the camera? Yes. 1 over 2.8. I have my point there. So 1 divided by 2.8, and that'll give us our frequency of 0.36, and frequency is in hertz, so we're going to put Hz. So we'll box that sucker. So pretty easy stuff, pretty straightforward. How many more are there? Okay, so 2 more. I think we more or less did for these all the way, because these next 2 are going to be the same style. We've covered every possible way to do these, so yeah, just do them. If you guys want to go ahead and check them when you're done, that's totally fine. And if you have any questions, okay, so I guess I X'd out 12. So we're not actually even doing 12, so really you just got to do 11. So hopefully you can get, ooh, tricky. 11 is different. So 11 they give you, what do they give you? They give you the period. You have the gravity and you got to find the length. Ooh, should I just do 11? I tell you what, I'm going to do it anyways, but how long is this video? 10 minutes? YOLO, let's do it. Just pause it, try to do it by yourself, and then unpause the video and check it. All right. So, Marla the maid is standing on Vanderbilt's dining room table. Yeah, that's pretty good. Let's refocus this. Blah, blah, blah. Marla is reaching up. She slips and grabs a hold of the chandelier. There's Marla. She's grabbing the chandelier. When she lets go, the chandelier begins swinging at a period of 1.6. So, we have our period, which is 1.6 seconds, periods in seconds. And so in other words, for it to swing back and forth one time takes 1.6 seconds. We have our gravity, which is 9.8. And we need how long? So we actually need the length on this one. Okay, tricky. Hopefully you guys paused and aren't cowards and just solved it yourself. So don't be a coward. Solve it before you listen to me do this. All right, let's plug stuff in. So with that being said, let's use our formula. Period equals 2 pi on the square root of length over gravity. Our period's 1.6, so we got 1.6 equals 2 pi on the square root of, we don't know length, over 9.8. Oh, tricky. Right? So now we got to get this length. So step 1, we need to get rid of this square root, because that's going to complicate things, right? So what I'm going to do, and there's a couple ways to do this, probably, I don't know, this is what I'm going to do. I'm going to divide out this 2 pi. 2 pi, divide out, goodbye. 2 pi. So now we have 1.6 divided by 2 pi. Let's just rewrite it. 1.6 over 2 pi equals the square root of length over 9.8. Okay, good. So you can either square both sides right now, or you can go ahead and do this. I would do this first and then square it so you're not dealing with like too many things. So with that being said, ooh, they did it a little bit different, but that's okay. All right, so I'm going to square this and I'm going to square this. If you square this right side, it's just going to take away the square root, right? So you're going to have length over 9.8 equals 1.6. Oh, I guess I should have got a calculator. I did not get a calculator ready. That's okay, because I'm doing it now. 1.6 squared is 2.56, so 2.56 over 2 pi. Now, I don't have a pi button on my phone, so we're just going to estimate 9.86. Now I actually have to do the math, so I'm going to go 2.56 divided by 9.86 equals 0.26. I'm going to round it. So length over 9.8 equals 0.26. So I guess we'll find out if our phone calculators are as accurate as having the actual pi button. Okay, so now we have just an easy basic formula. We just got to get length. So I'm going to do times 9.8. Since it's on the bottom, I'm going to cross that out. Times 9.8. So we have 9.8 times 0.26 equals length. So length equals, let's look at the key, 0.64. So let's see. Times 0.64. No, not times 0.64. What am I talking about? 0.26. I'm zoning out. I'm zoning out on this one. That's okay. Well, I didn't get the right answer at all. Guess I should have used one of those regular calculators. Okay. I'm going to do this one more time. 2.56 divided by 9.8 time. That doesn't make any sense at all. Well, okay. Hopefully you did it in the calculator where it makes more sense. Phones don't work good. That doesn't work good at all. You should have got 0.64 meters. I was getting all kinds of wacky stuff. So I probably rounded off. We did it properly, but we rounded a little bit off. You know what? I got a little bit of time. I'm grabbing a calculator because I need to prove I got this. We got this. We can do it. Okay, so let's do it right. So, all right, let's see. Open parentheses, 1.6 divided by 2, where's the pi button? I can never find the pi button. There it is. Pi, quantity squared. So does that make sense? You see that? 1.6 divided by 2 pi squared. Enter. Okay, 6.31. So this should have been 6.31. Now, times, what? 6.31. That times that. This does not make any sense at all. Dude, I am finding this answer. 1.6 squared divided by 2 pi squared. Okay, I'm going to do it again. 1.6 squared. Enter. It's 2.56, so I was right on that. 2 pi quantity squared. Enter. So that's 39.47, right? Oh, is that shadowy? There we go. So 2.56 divided by 39.47 equals, gives us 0.064 times 9.8, because we got to multiply that 9.8 over. Yeah, I knew I could do it. See? Never surrender. 0.635, which rounds to 0.64 meters. Boom! We did it. And that's how you do it right there. All right, good job. We did it. We're super, super smart. Maybe you guys got it before me. I guess, you know, calculators are better than phones. Good lesson. All right, if you guys got any questions, let me know. Jeez, oh man, 17-minute video. That's a little excessive, but that's okay. We're going to have a great day.